Is it fine, sir, now?
Yeah, it is fine. Yeah, just can you press the hide option? Hide option. Yeah, perfect. Good morning, everyone. I welcome you all to the morning session of the day. Today, it's our immense pleasure to have with us Dr. Parvathy. Ma'am is scientist, Fish Processing Division, ICAR-Central, and the topic chosen for our session today for deliberation by our esteemed guest is seafood handling and low temperature preservation. Ma'am, you're audible as well as the presentation is visible. You may start.
Thank you, sir. Thank you for inviting me for this presentation. So, first of all, a very good morning to the coordinators of National Refresher Course and all the participants. So I'll be handling with the topic seafood handling and lot. So already you know the previous speakers must have given you introduction regarding the importance of seafood. So just to brief through, seafood, it is one of the globally major food commodity. Especially it gives around 20% average per capita of the total animal protein, and it serves globally around 3.1 billion people. So you know the uniqueness of fish. The main thing is that it is an excellent source of all the nutrients, especially it has highly digestible proteins, and there is a presence of all the essential amino acids, the polyunsaturated fatty acids, especially the omega-3 fatty acids, minerals, and vitamins. And in general, the fish flesh contains around 80% moisture, 60 to 84% moisture, 15 to 24% protein, 0.1 to 22% fat, depending upon the species, as well as minerals around 1 to 2%. But there is a major problem with regard to the seafood preservation and its marketing, which is mainly on account of the catch uncertainty. You know, especially in the case of fisheries, it is the capture fisheries which is majorly contributing. So when it comes to the capture fisheries, there is an uncertainty in catch. We don't know how much will be the bulkiness of the catch that is obtained each time. So there will be preservation problems rising. Then the highly perishable nature on account of the nutritive components it has. It is rich in all the nutritional components, so it is more prone to bacterial decomposition, as well as it is rich in moisture, so it is more prone to decomposition. So then again, the high heterogeneity, especially with regard to the tropical seawaters, the main problem is that you get a lot of variety of fishes. Like there are different species that we are getting. So each species will have different storage stability. So when it comes to the storage as well as the preservation, each species should be specifically sorted out and it should be preserved. And the high storage as well as transportation costs. So it is very much important that you have an effective handling, processing, and marketing technology so that you can deliver the food item or the seafood in its prime quality to the customers. And hence, we need to develop newer supply chain models with effective management strategy. So what is post-harvest technology? So post-harvest technology involves all the treatments or the processes that occur right from the time of harvesting till it reaches the final consumer. So it is a post-harvest chain that is involved. Mainly, it is the cold chain. We should see that the post-harvest chain is maintained at a lower temperature, and it starts with effective or efficient harvesting procedures, transportation procedures, handling, storage, processing, preservation, as well as packaging. So the major post-harvest quality issues arises when there is poor handling practices, which is a major problem. Then other than that, there are food contamination on account of biological hazards, pesticides and antibiotic residues, mainly in the case of aquaculture species, the food adulterations, as well as other unhealthy ingredients that are being added. So what is the importance of post-harvest cold chain management? As mentioned, fish is highly perishable in nature and it requires efficient cold chain management. So it is estimated that along the cold chain, there is qualitative loss as well as quantitative loss. The qualitative loss mainly occur it is accounted to around 2 to 5%, and the quantitative loss or the physical damage is mainly it ranges from around 3 to 17% throughout the chain, which occurs maximum during the harvesting procedure. And so the key requirements that are to be included are strengthening of the harvest practices by proper measures, reinforcement of the post-harvest facilities like onboard facilities that should be there, the cold storage systems, the ice plants, the freezing or processing units, then the roads and transportation facilities, the modern as well as the hygienic wholesale as well as the retail markets. And again, there should be effective marketing system in the identified areas. So what do we mean by food hygiene? Food hygiene, it is the condition, it relates to all the conditions or the measures that is necessary to ensure that the safety and suitability of food at all stages of food chain is maintained or ensured. So this production of safe and quality fish and fishery products requires effective hygienic practices throughout the food chain. In the sense, the food chain means right from the harvesting till it reaches the consumer. So these hygienic measures, what they aim or they help in preventing or reducing the fish contamination as well as the microbial growth. So this handling procedure itself, there are different sections. Like first, there is an onboard handling procedure that should be followed. When it reaches the market, the domestic market, procedures followed, as well as when it reaches the processing unit, the procedures that have to be followed. And so the different aspects include the hygienic design of facilities on board during transportation, during the processing as well as distribution, and again the personal hygiene that should be followed, or the people involved in handling of this seafood. Then the cleaning procedures that should be followed, the sanitation, the pest control measures that should be followed. So all these should be covered during handling. So to generalize, the objective of hygienic handling practices is to land the fish in the same condition when it is at the time of catch within the limits of practicability under good commercial practices. So in general, the measures that should be followed for hygienic handling is to avoid the warming of fish. That is, the fish should be kept as cool as possible, because the temperature, the higher the temperature, the more it is prone to deterioration. It is estimated that for every 10-degree increase, there is about 2 to 3 times more spoilage taking place. So it should be kept as cool as possible. Then again, avoid mishandling of the fish. When you are handling the fish, it should be taken, it should be handled with care. Most often it is seen that in the case of onboard handling and all, fishes are thrown like, we should always think that fish is a food. It is used for consumption. So it should be handled with so much care. Then again, sorting of fish, especially in the case of onboard handling itself, the fishes should be sorted, because catch-wise itself, since it's a tropical country, we get so many variety of species, and each species have different stability. So once the catch, we get the catch, it should be sorted species-wise, as well as it should be sorted size-wise. Again, size-wise, the bigger fishes as well as smaller fishes. Smaller fishes are more prone to spoilage than that of bigger fishes. So likewise, it should be sorted separately. And again, the containers or the surfaces that we are using for holding or transporting of the fish should be clean enough. You should use chlorinated potable water. And again, as mentioned, the personal hygiene that should be followed at every stages of handling. So these are the general aspects that should be followed during handling of the seafood commodity. Now, coming to the technologies that are used to preserve the seafood. There are different technologies that can be adopted for preserving the seafood, right? From simple technologies like drying, chilling, etc., that are commonly being practiced, to highly automated technologies are there, like high pressure processing, the thermal processing technologies to preserve the seafood. And based upon the technologies that are being adopted, the product will have different shelf life. You can have shelf life of few days, as in the case of icing or chilling, to extended shelf life of up to years in the case of thermally processed commodities or ready-to-eat commodities. And again, based upon the investment involved, there can be low-cost investment technologies like drying is a technology, drying salting is a technology which requires very less cost to highly cost-intensive technologies. And it can be categorized, these technologies can be categorized in general into thermal processing as well as non-thermal processing. So in thermal processing, heat is involved, whereas in non-thermal processing, you are doing it either under ambient condition or under low temperature condition. So here we will be dealing with the low temperature preservation technologies, mainly the chilling as well as freezing. Now, what is chilling? Chilling, you must be well aware of the process. Chilling is a low temperature preservation, which effectively reduces the spoilage in fish. So it should be done at a low temperature, and it should be done. Care should be taken to see that it is done quickly and it is kept chilled and handled carefully and hygienically. And as mentioned, for every 10-degree reduction, the principle is that for every 10-degree reduction in temperature, the rate of deterioration decreases by a factor of 2 to 3% because the bacterial action or the enzymatic action is reduced. So the objective is to cool the fish without a delay as quickly as possible to a low temperature, but without freezing, or there is no change of state happening. Normally, chilling is done at a temperature of 0 to 2 degrees Celsius. So altogether, chilling cannot prevent the spoilage, but the colder the fish, the greater will be the reduction in the bacterial, enzymatic, or other oxidative changes. So the chilling methods, basically the chilling methods, you can go for air chilling or icing. Icing is the normally practiced method, especially in the case of if it is on board on the vessel, we go for holes or insulated boxes. So the fishing vessels will have fish room or holes, which should be strong enough. It should be corrosion resistant. It normally comes just below the wheelhouse, so it should be corrosion resistant, easy to clean with smooth surfaces, and there should be adequate facility for drainage of the meltwater, because we are storing the ice as well as fish. So whatever meltage is happening, there should be adequate drainage facilities. It should be insulated and watertight. So in the case of fish rooms or halls, we can store or ice the fish in different ways. So the three common methods is bulking, shelving, and boxing. So you can see the pictures over there. Bulking is wherein the fish room can be divided into pounds by using pound boards supported by stanchions, or there will be vertical boards that can be kept for holding the pounds. So pounds, normally there is an ideal size that is given, and in this pounds, in each pound there will be fish to ice. Normally in all the cases, the fishes should be layered with ice. So fish to ice layer will be around 45 centimeter, not more than that, because otherwise it will result in pressurization of the lower layer of the fish. So fish to ice ratio is maintained at 45 centimeter thickness with the top and bottom covered, or each layer should be covered, especially the top and bottom layer should be covered with ice. Whereas in the case of shelving, in the case of shelving, there are different shells. Like in the case of water, we are having shells. There will be removable shells of around ideally 23 centimeter for holding the fish, and each shelf will be having a layer of fish and ice of 5 centimeter. It is much more better to have shelving, but the problem is that the space requirement is more and the labor involved is also more. And yet another which comes as intermediate, and which is a commonly practiced one, is using boxes, that is insulated boxes, puff insulated HDPE boxes, which should be strong and robust, which is light, which is stackable, which should have drainage facility for draining the melt water, as well as should have good insulation properties. So this is the main method which is followed. Icing is the main method which is followed. Other than that, in onboard vessels, we have the chilled seawater system, chilled freshwater system, refrigerated seawater system, then cold air facilities or cold rooms will be there. So coming to the icing, so icing is a relatively common means wherein during handling, transportation, and marketing, we use ice for bringing about preservation, and it is a relatively short-term means of preservation. So there are different forms of ice that are available, like block ice, plate ice, tube ice, soft ice, flake ice, etc. In domestic market, we normally go for block ices, which are crushed and used, and flake ice is also popular one. Flake ice is much more reliable, and flake ice is used in processing units. The thing is that the cooling efficiency will be much better because the surface area of flake ice is better, so you will have better contact with the fish, and it is relatively dry and clump formation will be lower. So when coming to the ice, why we are using ice? Ice is having a high latent heat of fusion. So a large amount of heat can be removed from the substance to be cooled. So normally 1 kg of ice can absorb around 80 kilocalories of heat. And theoretically, it is estimated that around for bringing about a temperature reduction from ambient temperature, say 30 degree to 0 degree, around 30% of ice is enough. But however, though we want to maintain the temperature, and also there will be heat coming from the environment. So to cope up with that, it is generally recommended, especially in tropical condition, it is generally recommended to have fish to ice in the ratio of 1:1. So again, it should be seen that it is there should be complete contact of fish with the ice, and 1 kg of fish generally requires 1 kg of ice. Now, what are the different factors affecting the rate of spoilage in chilled fish? There are extrinsic factors as well as intrinsic factors. As mentioned, extrinsic factors, temperature has a major role to play, as well as the physical conditions, so physical damage that is happening, or the handling that we are adopting. So in the case of temperature, the lower temperature, it slows down the rate of fish spoilage, and the faster we are bringing about a delay. When there is a delay, it is more prone to spoilage. So the faster the rate of lowering, more effective is the preservation. And again, there are intrinsic factors, the species-wise, size-wise, seasonal-wise. There are factors which affect the spoilage. If you compare, you can see that based on the shape itself, the flat fishes will have slower rate of spoilage compared to round fishes. Then the size, the larger fishes will have slower rate compared to smaller fishes. Lean species will have slower rate compared to fatty fishes. Thick-skinned ones will have slower rate compared to thin. Then again, freshwater fishes will have comparatively lower spoilage rate. Then tropical fishes will have when we are icing it properly, it will have more shelf life when compared to temperate fishes. So it depends. It depends upon the intrinsic factors as well. So what is the shelf life of ice fish? So shelf life is defined as the maximal period during which the predetermined attributes of the food can be retained. So normally the spoilage pattern is like there are 4 different phases involved in it. The phase 1 and 2, wherein there are the signs of spoilage are very less, so it will be in fresh condition itself. So both this phase 1 and phase 2 are brought about by the autolytic changes, mainly by the enzymes involved in it. So as soon as it is caught, the fish will be very fresh. It will be having a CVD and delicate taste. And this phase lasts for around 1 to 2 days. And the phase 2, when it commences, there will be loss of the natural flavor as well as odor. It will be that the fishy taste will start going off. It will become more of neutral in nature. And once the phase 3 and 4, which is on account of the bacterial changes happen, it will start showing spoilage, that ammoniacal of odor of flavor starts coming in. And by the completion of phase 4, it will be completely putrid and it becomes inedible. So as mentioned, this tropical species can be kept longer because the ambient temperature will be much higher when compared to the temperate of colder water. So we are bringing about a greater reduction in temperature. So it is always seen that the tropical fishes can be kept longer than that of the temperate water or colder fishes. And it is seen that if we get 1 to 2 weeks for temperate fishes, you'll get say higher period for tropical fishes. And again, delay in icing is also a factor which affects the shelf life. Immediately as you ice it, the better will be the shelf life when compared to delayed icing. And basically or primarily, we determine the shelf life of fishes, or a layman can determine the shelf life mainly by sensory evaluation, especially by the external appearances like the color of the ice. You can see in the picture, you can see how the color has changed from a fresh one to a putrid one. Then the gills, the color of the gills, then the external appearance, the fin color, the gill color. So all this by the sensory evaluation itself, we can see the stability. Other than that, there are other biochemical tests that can be carried out, like TMA, TVBN, then other oxidative changes by estimating the peroxide value, as well as the microbial count. So this is the studies that have been carried out in different species. So if you see the first table, you can see that in the case of fatty fishes like mackerel or oil sardine, if you don't delay, or if you're immediately icing the fish, you'll get a storage life of around 1 week, 7 to 9 days in fatty fishes. But if you delay the icing, say if it is delayed for 6 hours to about 9 hours, you will get only a storage life of 1 day. And again, if you see tilapia and other farmed species, instead of getting 16 days, say 2 weeks, it is delayed to around 1 day in the case of tilapia, if there is a delay for around 12 hours, and around 4 days if there is a delay for around 9 days. So it's very important that it is properly iced and immediately iced. And again, to substantiate the same, the temperate water as well as tropical water, if you compare the catfishes and trouts, you can see the tropical water fishes can be kept longer than that of the temperate water fishes. Now coming to the next preservation, which is the freezing. Freezing again is one of the most important processing and preservation methods. So here, again, we are cooling to a very low temperature, below that of 0 degrees Celsius, wherein there is a phase change happening. That is, the water in the fish is converted to ice. Normally, freezing we do at -40 degrees Celsius, and further to bring about a core temperature of around -20 degrees Celsius, and further it is stored at -18 to -20 degrees Celsius. So what are the advantages of freezing? There will be minimal, if it is properly done, if this preservation technique or processing technique is properly done, there is minimal loss of the quality. There will be arrest of the bacterial as well as enzymatic activity, and it will be similar to that of fresh fish, and you will have an extended shelf life. In the case of chilling, normally you'll get a shelf life of around 1 week, depending upon the species. You will get, for fatty fishes, you get around 1 week. To freshwater or lean fishes, you can even get up to 20 to 25 days. But that is for a short term. That is a short term preservation. Whereas in the case of freezing, you can get extended shelf life of 6 months and more. And again, when freezing fish, the major constituent of fish is water. And other than water, it also contains several other organic as well as inorganic components. So when you are freezing it, you're crystallizing part of it and some of the solubles. And since there are other solubles involved, in the case of pure water, it is 0 degrees Celsius. But when you're freezing the fish, there is a there is a depression of freezing point happening, and freezing of fish happens at -1 to -2 degrees Celsius. So if you look into the freezing curve, there are 3 different stages happening when you are freezing the fish. So immediately there is a stage 1, wherein from the ambient condition, it is falling drastically to 0 degrees Celsius. It is the stage 1. This is followed by, in some cases, there is a supercooling taking place, wherein the temperature goes below the freezing point, but no freezing happens. And the actual freezing starts from say in the case of fish, it starts from around -1. This crystallization starts, and there is a transformation stage that is taking place from -1 to -5. And this is the main area where freezing is happening. That is around 80% of freezing occurs at this stage, which is also called as the zone of maximum ice crystal formation. And by around -25 degrees Celsius, almost 90% of freezing occurs. So depending upon the time taken for this thermal arrest or zone of maximum ice crystal formation, it can be categorized into quick freezing as well as slow freezing. That is, if it is quick freezing, it takes less than 30 minutes, whereas in the case of slow freezing, it takes more time. More time is required. And another expression is the speed at which. One is the time required for crossing this stage, as well as another is the average speed at which the ice front moves. That is expressed in terms of millimeter per hour. So in the case of slow freezing, it is 2 mm per hour or less, whereas in the case of quick freezing, it ranges from 30 to 100. That is, quick freezing takes around 2 to 30 mm per hour, whereas in the case of it is ultra rapid, of it in those cases it will be so rapid that it takes around 100 mm per hour. Ice front movement will be around 100 mm per hour. So it is always recommended to have quick freezing, because the damage or the quality changes associated with quick freezing is very less when compared to that of slow freezing, because slow freezing results in bigger ice particles. So it is more prone to damage of the it is more prone to other damages like protein denaturation or other physical damages when compared to quick freezing. Now, coming to the freezing techniques, the first freezing technique was man-made, wherein ice salt mixture was used. So the idea behind it was depression and the freezing point. So this ice salt mixture was used as a freezing technique. This was followed by different mechanical refrigeration techniques that is now widely being used. So again, this mechanical refrigeration can be divided into direct as well as indirect system. So in direct system, the refrigerant will absorb the heat directly from the material to be cooled, whereas in indirect system or brine system, the refrigerant will absorb the heat that the brine absorbs from the material. So brine is acting as the medium. So from the brine, the refrigerant will absorb. So that is the indirect or brine system. So based on this principle, there are 4 methods, which is air freezing, indirect contact freezing, immersion freezing, as well as cryogenic freezing. So in air freezing itself, there is freezing in still air or by just placing the product in cold rooms, wherein the packaged or unpackaged marine product can be frozen in air, and the temperature range from -18 to -40. And these products are placed in aluminium trays in pipes where the refrigerant is circulated. Here, since the air circulation, there is no forced air circulation, the freezing rate is very slow. Normally, it takes around 12 hours or more, depending upon the load that we are giving, or the temperature or packaging condition or the arrangement of fish, as well as the size of the product. And yet another is in the air freezing is the tunnel freezing or air blast freezing, which is normally being practiced in processing industries, wherein the cold air is circulated at high speed. And here you're keeping the product. It can be either batch type or continuous type, wherein you're keeping the product in meshed belt, and it is passed through insulated tunnel at temperature ranging from -18 to 34. And the speed ranges from 1 to 20 meter per second. And innovation in this regard is the spiral belt freezer, wherein the belt will be bent laterally, and there will be still self-stacking as well as enclosing belts for compactness, better compactness. You can keep on for IQF, especially for IQF products, we are going for this air blast freezing, spiral freezing. You can use either unpacked product or packed product, and there will be different types of products can be used. There is large flexibility with regard to the product as well as the freezing time. Their airflow can be either horizontal or vertical. Normally, vertical is more efficient when compared to the horizontal type. And another is the fluidized bed freezing. So it is it's an improvement over the continuous belt. Here, what happens is cold air is blown from the bottom. So what this cold air, it keeps or it suspends the solid particles in this cold air. So there will be complete coverage over the product. So air velocity is normally, there is a high air velocity of around 120 meter per minute, and temperature normally ranges from -35 to 40. But the disadvantage is that it is applicable for only uniform small pieces like small shrimps, small fillets, etc. And the advantage is that there is rapid rate of freezing, there is less product dehydration, and there is no distortion of shape. It is not possible to freeze irregular products, so it is good for application in uniform products. There is next category, which is the indirect contact freezing or plate freezers. Normally, it is the plate freezers, which is categorized under this. So, freezing a product by keeping in contact with metal surface cooled by some refrigerant. So, you're using a refrigerant which cools the metal surface. So, you're keeping the product on the metal surface, which is cooled by the refrigerant. So it can be like it consists of a stack of horizontal cold plates. You can either have horizontal or vertical type of freezers with spaces. So in between the spaces, you are layering this packaged product. So it will be like a multi-layered sandwich type, wherein there will be cold plates and as well as the products in layers. So you will have better contact between the plates, so facilitating effective heat transfer. And these vertical freezers, there are horizontal plate freezers which are normally used in industries, processing industries, and there are vertical to have better space. So there are vertical plate freezers that are being used in the onboard fishing vessel. You can see the picture over there. So which is the diagrammatic representation of the same. So you'll be having normally horizontal plate freezers, you'll be having around 15 to 20 plates, which is packed for about, the product will be around 3 to 4 centimeter that can be frozen in around 1.5 to 2 hours. And next is the rotary drum freezer. Rotary drum freezer is again refrigerated. The refrigerant will be passing through stainless steel drums, and it will be revolving at a preset speed depending upon the product that is to be frozen. So it can be adjusted. The freezing time can be adjusted by adjusting the speed of the revolution. Here you use unpacked products like fish fillets, shrimps, thin products can be used for rapid freezing. There is a third category, which is the immersion freezing. Here in immersion freezing, you're directly immersing the product in the refrigerant or the coolant. That is, you can either go for immersion or by spraying, and the refrigerant or the coolant will remain liquid throughout the process. And here it should be seen that the freezers that are used should be non-toxic, it should be inexpensive, it should be stable, inert, it should be of low viscous with low vapor pressure, freezing point, and high values of thermal conductivity. And it should have a low tendency to penetrate to the product with not much effect on the, because you are directly using the refrigerant, it should not have any effect on the organoleptic properties. And normally the aqueous solutions like propylene glycol, glycerol, sodium chloride, calcium chloride, etc. can be used as refrigerant. But the problem is that since you're using it continuously, there can be cross contamination for the subsequent batch, which is a disadvantage in this category. And there is the cryogenic freezing. So difference between cryogenic freezing as well as the immersion freezing. The immersion freezing is that here again it is much more rapid by exposing the product to the cool refrigerant. But this refrigerant will undergo a change in state since it is absorbing the heat from the sample to be cooled. There is a change in the state happening, whereas in the other case there is no change of state. So the most common food grade cryogenic freezer that are used is nitrogen, liquid nitrogen, carbon dioxide, etc. Freon is also used, but due to some environmental issues, it is now being seldom used. So rate of freezing obtained here in this case, it is the best method of freezing. The rate of freezing is much higher than that of the other methods like air blast freezing or plate freezing or liquid immersion freezing. And here currently liquid nitrogen, the advantage is that the dehydration loss will be very less. The oxygen is excluded in this. The freezing damage that is happening is very less because there is quick freezing taking place. And the equipment involved is very simple. It can be used for continuous operation at different production rates and product size. The investment, the initial cost involved is very less, and you can it is capable of producing high production rates in minimal space. But the disadvantage is the high operational cost because the cost of liquid nitrogen is very high. So this is one of the major limiting factor in this regard. And other than liquid nitrogen, you can also use carbon dioxide, which is absorbed or retained in the product. And this entrapped carbon dioxide, the only thing is that entrapped carbon dioxide should be removed before it is packing. And as mentioned, Freon 12 is also a refrigerant that can be used. Here the advantage of using this Freon is that it has lower operational cost when compared to nitrogen, but the disadvantage is the concerns regarding the ozone depletion. Now, what are the different changes that happen? There will be volume change, there will be expansion. Since the water is converted into ice, there is an expansion of up to 6% when you are freezing the fish, whereas in the case of pure water, it is 9%. And it depends upon the composition. What is the food composition, the nature of the water, the temperature range, etc. adopted. And other change is that since pure water is mostly the pure water is being frozen, there will be concentration of the non-aqueous constituents taking place. And thaw drip is a major problem. So what happens is the exudates in the tissue fluids that are free flow on thawing, it will be coming out as exudate. And this is mainly happening on account of the protein denaturation as well as the cell damage. And you can see that the thaw drip will be more if it is slow freezing when in comparison to that of the quick freezing. It varies from around 3 to 5% to up to 20%. Yet another problem is the gaping of the fillet that is happening because of the connective tissue problem. It will fail to hold the muscle blocks together. And this mainly happens when you're freezing the fish before or during rigor. And this is mainly because of the muscle contraction. And what happens is when you take the fillet, there will be gaps. When you view the fillets, you can see gaps over there. And this is an issue that is noticed in the case of frozen products. And yet another is the recrystallization and desiccation, which is a change that is happening. That is the size and shape of the ice crystals. During freezing it is unstable. It undergoes some changes, and there will be a rearrangement happening that is called as recrystallization. And desiccation is another problem wherein the ice there will be sublimation of ice from the surface. This mainly happens if it is not properly glazed or if it is unpacked. And what happens is it looks like to have a chalky white, yellow or brown discoloration or wrinkled appearance, which is unappealing in nature. And this mainly occurs if there is a major temperature difference in the cold storage facility, then high storage temperature, greater air velocity. All this results in this desiccation. So it is better to have, to avoid this, it is better to have constant, proper storage temperature, proper packaging, glazing facilities. And another issue is the discoloration. This occurs in fishes like, especially the green-brown discoloration occurs in fishes like tuna, wherein the browning occurs due to autooxidation of the myoglobin to metmyoglobin. And there can be greening in some species, wherein the pigments, there will be oxidation of the hemochrome. Then all this can be avoided to greater extent by proper evisceration techniques. And if it is the shrimps or lobsters, there will be changes in that color, that pink, particular that pink color, which is on account of the astaxanthin, is lost to greater extent in these shellfishes. Then toughness is another problem. The texture will be much more tougher in the case of frozen fishes, which is on account of the protein denaturation. So just to see the storage life, if you see, if you are storing it at -18 degrees Celsius, if it is fatty fishes, you'll get around, if you're getting around 4 months, it can be extended. If you're reducing the temperature for storage, you can extend it up to 1 year. And it can be, if it is lean fishes, it can be extended from 8 months for -18 degrees Celsius to around 24 months. That is, to up to 2 years, you can extend it if you're storing it at a lower temperature. So the lower the temperature you are storing, the higher will be the stability. So just to compare, you can see if it is chilling, it is a short-term storage. You will get up to 1 month depending upon the species, whereas freezing is a long-term preservation technique. You can get from 6 months to more than 1 year. And the storage temperature for chilling, it is normally chilling or icing, it is around 0 to 2 degrees Celsius, whereas in the case of freezing, it is around -20 to -30 degrees Celsius. Chilling is relatively cheap when compared to freezing, and the product will resemble, if it is properly chilled, it will resemble, whether it is chilling or freezing, it will resemble the fresh fish. And the low technology is involved in the case of chilling, whereas you need much more sophisticated equipments, like you want freezers as well as frozen storage facilities for freezing. And low skills are required for chilling, whereas freezing requires high skills. And chilling, you just, if you're icing it, what you need is a proper ice as well as insulated boxes, whereas in the case of freezing, it is generally static in nature. It is not portable in nature. Coming to the different products, the chilled products, it is a common value-added product in domestic market as well as foreign trade. And if you look into the foreign trade or international market, it is mainly the sashimi, sushi grade tunas, because it is to be consumed in raw conditions. So it should be properly chilled and used. So this sushi sashimi grade tunas are used mainly in Southeast Asian countries, Japan, etc. And other than that, there are different cuts, there are different forms of sashimi products that are available. Then when coming to the domestic market, now it is gaining more importance in domestic market. If you go to the retail markets, you can see in the urban areas, there are array of marinated. You can get the product either in the whole form, you can get it in different cuts, like steaks you can get, in different dressed forms you can get it in marinated, different types of marination, which is ready to cook or fry. So when you're marinating it, the additional advantage is that you're adding acid to it, you are adding some spices, which again brings about preservation. So this can be either air packed, vacuum packed, and chilled, and you can get from 2 weeks to even up to 1 month, depending upon the raw material, the ingredients that are being used. Then frozen products, earlier the frozen products were more oriented towards the export, but now if you see, since there is a demand in the domestic market as well, there are a number of innovative products that have entered. So mostly you're getting it as individually quick frozen, quick IQF products. You are getting it rather than block frozen. Block frozen is mostly going as in the international market. So it will come in different attractive moisture-proof containers, and it is stored at -20 to -30 degrees Celsius. You can see different IQF forms like lobsters. You can see then different forms of shrimps. You can see then different fillet forms. You can see And other form is stretched shrimp or nobashi. Nobashi is nothing but normally the shrimp will be curly, and if you want to have better appealness or better market value, what you can do is you can increase the length of the peeled and deveined shrimp. That is about there will be an increase of around 1 to 2 centimeters. So for that, what is done is there will be cutting, parallel cutting is given at the bottom of the shrimp or and you are applying a pressure over it, so it will remain stretched. So this is called a stretched shrimp. So this can be used for different marination purposes. It can be used for different battering, breading purposes, because there will be more surface area and there will be more pickup when you are doing coating. Then there are other forms like cooked butterfly shrimps in frozen condition coming, skewered shrimps. All these have more of rather than domestic value, it is more of export oriented. Skewered shrimps are there, shrimp head-on cooked shrimps are there. So these are a few categories that are coming. So you can see, as mentioned, there are different forms like frozen fish, fillets, then battered breaded, again it is coming in frozen forms. Then yet another category, you must have had a previous lecture on this, means surmi and related products. So these are also coming as frozen form. This comes as blocks, wherein fish meals are coming as block, because it is a raw material for different value-added products, especially battered breaded products. Then this water-leached form of fish meals, which is called as surmi. Surmi, again, it has a high market, especially in Southeast Asian countries, it has a high market. It is coming in frozen form. So likewise, there are different forms of frozen as well as chilled forms that are available in the market. So to conclude, low temperature preservation is the best method that can be used to retain the quality and freshness of the fish for a longer period. Then if coming to the chill storage, if that is without adopting frozen condition, you can keep the fish for around 4 to 20 to 20, even 1 month, depending upon the species as well as condition. And frozen storage ranges from 6 months to more. So the different factors which influence are the condition at the time you're catching the fish, the handling procedures that are following, the process as well as the product development involved in it, the packaging that you're adopting, the glazing of the product, the method that you're adopting, then the storage temperature, the stacking method, transportation techniques, etc. So all these factors together can be termed as the product processing and packaging as well as the time temperature tolerance factor. So based upon these factors, you can determine the stability of the product. Thank you. So thank you. If you have any queries, you may please ask.
Thank you, ma'am. If there are any questions, please ask. Ma'am is with us right now. The microphones have been turned on. You can ask the questions, be it on chat or voice itself.
Any questions?
Any questions, please ask. We have a few minutes. There's a question in chat. Any study on slurry ice?
Yes, ma'am. Actually, number of studies have been carried out in slurry ice, especially in CRT. Number of studies have been carried out, and we have got promising results. The only problem is that when you're using slurry ice, there is a slight uptake of salt happening. Otherwise, the quality-wise, if you see, there is an extension of shelf life happening when it is compared with that of normal ice.
question? Mostly thank yous are coming in, ma'am.
Thank you, sir.
So on behalf of the participants and on behalf of the organizing committee, we want to extend our heartfelt gratitude for being with us and sharing this lovely concept with us. Thank you, ma'am. Thanks a lot for being with us. We look forward to future collaborations with you, ma'am. Thank you.
Thank you very much, sir. Thank you for inviting me for this presentation. Thank you. Bye. Shall I leave, sir?